This is our last really lesson for the year. Okay, so we're finishing the matrices, and that was our last topic. So I'm going to do two things. First thing, I'm going to do a complicated question with one of these matrices that have sine theta, cosine theta, and then next part is going to be a combined transformation. So this is a question from this year exam. You've got it written. I'll just read it for you. A line with n points 3, 4, and -1, 0 is reflected to point this ugly coordinate and a half minus square root 3 over 2 respectively. Respectively means that the 3, 4 was transformed to that and that to that, and it tells us that it was reflected, not rotated, not any stretched or sheared or whatever, is reflected. So we need to find the gradient of the line of reflection. Okay, just a quick reminder. Okay, I can have, let's say, a line of reflection. Okay? Let's say that with a certain angle of theta. Okay, so if I have a point, let's just take the easy one, -1, 0. Okay, this is -1, 0. That's going to be reflected somewhere here. Okay, remember that folding action. Remember I did it with the arrow. That's called reflection. Okay, so that's all I've got. Obviously, and that you are given that equation. You're getting two kind of matrices, two kind of equations in your form sheet, in your information booklet. It's one for reflection and one for rotation, also with angle theta. They're very similar but not the same. Okay, so because they say reflection, we use that one. And what they're asking us here, okay, is to find the angle. So far, all the questions that I've been doing with you in all the transformation is given a certain point, find the transform point. So we had to go, and that's answering your question from a minute ago. If you told that you rotated by 90 degrees or reflected along the line y equal -x, you are not giving that. You're not giving the formulas. You have to figure them out with a 0, 1, 1, 0. Okay? It takes a minute once you kind of remember how to do it. It shouldn't take more than a minute. And then it's just about multiplying the matrix by your points. But now we're giving that point and that point, and we have to find the angle. So it's a little bit different. Yeah, I thought we'll just do that. So, what should I do? I'll pause here and see what you guys think. Okay, so I think we got it. What we got to say is, all right, if this becomes that, then if I multiply this matrix by the original point, I'll get that point. I'll start writing that. Cosine 2 theta, sine 2 theta, sine 2 theta minus cosine 2 theta, time the original point, and I gotta write it in the column. Okay, 3, 4, equal that one. -3 plus 4 square root 3 over 2, 4 plus 3 square root 3 over 2. Okay, so that's one set of equations. Before we start doing anything else, let's try and write another set of equations. I can write, okay, cosine 2 theta, sine 2 theta, sine 2 theta minus cosine 2 theta. And I can activate this matrix or multiply it by -1, 0. Right? I can also do that. And now we'll get half minus square root 3 over 2. Okay, so I've got to do these two equations. Now I'm going to have to translate that to normal equation. Okay, I'll just do that time that time that. But before we do that, if you had to choose just one, I can tell you, you only need one. You don't need to do both. Which one would you do, the top or the bottom?
0.
The bottom one. Because you've got already a 0 there. You don't want to mess around with that nasty number as well. But you're right, mainly because there's a 0 here. Right? So that times that, already there's going to be a 0 there. That time there's going to be a 0 there. So you got to be clever here. You don't need both of them. If you start working on this equation, you might as well be sent to an asylum. Okay? Alright, so we don't want that. Okay, so I'm going to pause here, raise a bit, make some space. Well, let's just carry on. Okay, So, how should I write that? Help me out. Write down so now we need to break it down. We need to write an equation. So, minus cosine 2 theta, that times 0 is 0, equal a half. Okay? Alright? You see where it's going, okay? And then the next one, minus sine 2 theta equal? Okay? That's actually really easy. Can you see how easy it is? If we went that way, it will be a nightmare. It's possible, but you'll have simultaneous equation. You'll have a mixture of cosine and sine. You have 3 cosine 2 theta plus 4 sine 2 theta. The cosine and sine will be tangled up, and you're going to have to untangle them. Simultaneous equation. You know how to do it, but you don't want to mix the cosine. You've got a simple answer, okay? So let's write that down as cosine 2 theta equal half. That's special angle, isn't it? What can we say 2 theta is equal to? Between 0 and 360. How's your trick doing these days? Which angle will give you cos half? 60. Yes. Okay. So 2 theta equals 60. Okay. But that's not the only option, right? Right. Cosine 60. That time that will be 1 and 2. There's another cosine that will give you 60. Remember, there's always two answers for in trig. What's that?
The other angle is 30.
Yeah. That one, isn't it? Quad 1. When is cosine positive? First and the last. Okay? Let's try trig. Okay, we're not going to do trig here. Well, you need to know trig. Okay, so cosine and sine and tan, we're always going to have two answers. So one is 60. The other option will be, you can call it minus 60, but if we want it positive, it will be 300. So we have two options. I'm not going to solve it yet. Let's look at the next one. Okay? Sine 2 theta equal square root 3 over 2. Another special angle, which really is the same. 2 theta will be equal to, let me tell you, 60 is also one of them. Okay? Right? If this is 1 and this is 2, that will be square root 3. Okay? Remember this? You've done that last year maybe. Okay? 2 squared minus 1. Okay, I'm not going to get into that now. Okay? So that's one option, 60. What's the other option for sine? Where else sine will be positive? In the second quadrant. So what will that be? This is 60. This is obviously also 60. That will be how much? 120. Okay, so that's just normal trig question. So you've got two possibilities for 2 theta here. I'm not even solving theta yet, but 2 theta can be either 60 or 300. And here it tells me that 2 theta equals 60 or 120. Which one does it have to be? 60. Okay? Do you understand what I'm saying? I've got two sets of equations here. I've got two sets of equations. That's where we start. Well, we start from there. Two sets of equation. This equation told me, listen, 2 theta is either 60 or 300. The second equation told me, listen, 2 theta is equal 60 or 120. So it must be 60. Okay? It can't be that one. This is the answer. And now we just need to finish it up. Theta equal to? Okay? Alright? I'll just recap what we've done. Okay? So we were told that these 2 points under a reflection along a certain line of theta became these 2 points. Find the angle. Right, I used the matrix of reflection along the line of the angle theta to see what's those that became that. So that times that becomes that, which is very nasty. I don't want to go there. I don't need it. And then I multiply the same matrix by the second point, and that's a little bit more civilized because of that 0 here. What I'm seeing in the exam that they did yesterday, okay, so these are live questions from last week exam, they actually make the work easy. If you know what you're doing, then you're actually not working that much. Matrices, in theory, you'll see it next year when we learn about, I'm just going to pause here because I'm just talking, okay, so I'll be with you back in a second. Okay, Larissa says, very correctly, she says, sir, is this the answer to the question? And I said, yes, but obviously I'm wrong. They're not asking for the angle, they're asking for the gradient. Okay? So if this is my Cartesian plane, and I know that the line of reflection was angle 30, that's still not the gradient. Okay? How do I find the gradient? Tan. Okay? Right? So, right, that equation is y equal mx, where m is tan theta, tan 30 in this case, which is half. Alright? Thank you very much. Okay, I'll pause here before we move on to the next bit. So what we've done now is, it's not a new thing, but you didn't see questions like that before, and they're not easy. The second thing, which is our new topic today, is a combination of transformation. So, for example, what I'm going to ask, what you can be asked there, and we'll do one of the questions in the exam, but I'll start with a simple one, is let's say I want to transform a whole bunch of shape, a bunch of coordinates. What is a shape? A shape is a bunch of coordinates. Okay? So I want to transform a shape, first of all give it in 90 degrees anti-clockwise, and then I want to give it another rotation of 90 degrees clockwise. Sounds a bit weird, isn't it? You're not going to get a question like that. It's too easy. What will happen to the shape? Nothing will happen. You'll get the same shape. Okay? Now, the question they will ask you is not to tell me what happens to the shape. What most of the time they'll ask you is give a simplified, what are the words they use? Simplified matrix. Let me just find a simplified single matrix that will do that. So what will be, just try and guess out, what will be the simplified matrix that, like you guys say, is not going to do anything to that shape? The identity, well, we're going to look at it, okay? It's going to be 1, 1, 0, 0. We need to come up eventually with the answer that should be 1, 0, 0, 1. Okay, now, that kind of question probably not going to be an exam, that'll be too easy, but I want to demonstrate solving it to show you that you get indeed the identity matrix. So, to cut up a bit of time, okay, Larissa, you asked, do you need to remember these matrices? You don't, but I'll show you how, remind you how we do it, but I kind of cheated just to save us some time. So I took this from the book. So the matrix rotation for 90 degrees anti-clockwise is 0, 1, minus 1, 1, 0. Let's do together the 90 degrees rotation clockwise. Okay? So remember, we're looking basically these two vectors, 1, 0, 0, 1. And we're asking ourselves, 1, 0, what does it become? 90 degrees rotation clockwise. It will become 0, minus 1. This one, let's draw it in red. This one is going to become there, so I'll draw it in red as well. 0, minus 1. Okay? And the 0, 1, this is clockwise, right? Yeah. This one will go over there, right? So we're going to call it, what is it? 1, 0. Okay? So straight away I can write that down. 0, minus 1, 1, 0. Okay? I mean, how long did that take us? 2 minutes? As long as you remember what you're doing, maximum 2 minutes. So it's no need to remember it. Okay? Yeah, and then just check that we got the right one. Yeah, okay. Now, how do I get a single matrix? I've got two matrices. You time them. You said that, right? You timed them, you're right. Okay? You timed them. So, but the question is, which one do you come first? The one that, well, yeah, well.
Isn't X first?
So it depends what we want to do. So you think about, let me just get rid of that. So let's say we have a certain point, X and Y. That's the coordinate that we operate on. Okay? I'll write it down here. So I'm going to have two matrices on it. Here, we're going to put the one that we should do first. Okay? Because that's next to the point. So we're going to multiply this matrix on X and Y. Transform it first of all. And then multiply it by the second one. So it's a little bit confusing, okay? This one is going to be the first, and this is number 2. What did we say we're doing first? Let's say this is 1 and this is 2. Okay? So we first of all transform it at 90 degrees anti-clockwise. So I'm going to write down 0, minus 1, 1, 0. Okay? And then I'm going to do 0, 1, minus 1, 0. Okay? Now, if, for example, I gave you specific points for x and y. Let's say I said x is 1, y is 0. Then I could find that. I will multiply, first of all, that by that, get another coordinate, and then multiply that by that. But actually here, they're not even giving you a certain point. And they don't want to know what's the transform. They want to just get the single matrix. So what I can do, this is the kind of newish thing, I don't even need to multiply by x, y. All I'm going to do is just multiply these two matrices together. And that's going to be the single matrix. Understand what we're doing? Instead of transforming first and then transforming two, let's multiply the matrices. I'm not really proving to you, but that's going to be our single matrix. Okay, so let's see what we get. Boom, boom. What is that? 0, 1 times 0, 1 is 1. 0, 1 times minus 1, 0. 0, right? 0 times minus 1, 1 times 0 is 0. Minus 1 times 0, 0, 1. Minus 1, 0 times minus 1, 0. 1. And we got the identity matrix. Exactly. So xy will be the main xy, which is what we expected. Now, interesting thing, okay, I'm adding a little bit. What do you reckon will happen if we did it the other way around? 0 minus 1, 1, 0, 0, 1, minus 1, 0. So first of all, we'll do 90 degrees clockwise, and then 90 degrees anti-clockwise. What should you get?
The same.
You should get the same, and you will get the same. And you will get the same. But does that mean if I have two matrices, A and B, and I multiply them, is that always going to be equal to BA? No, I think we did talk about that in the beginning. When we multiply matrices, it's not like numbers. It's not always going to be the same. In this case, it was. But I'm going to just show you one case where it isn't, just so you'll see. Okay, so before we move on to the exam question, which is not too difficult, I just want to show you an example where the order does matter. So here, this could be a question where I'll ask you, all right, I want you to find a single matrix that will show you transformation where we first of all reflect along the line y equal x, okay? And then we rotate it 90 degrees, let's say anti-clockwise. Okay? That's first operation, that's the second. And then I want you to try the other way. So first of all, do rotation 90 degrees, and then reflection along the line y equal x. So again, to cut short the time, I've already written you the matrix. Each one of these matrices in the exam condition, you have to reproduce it. But as we said, it's actually less than 2 minutes each. Now, if I do first reflection, that rotation, I need to write the matrix multiplication like this. This is what you do first, you put it on the right. This is what you do second, you put it on the left, because that works on the coordinate. Let's quickly find out what that is. Okay? 0 minus 1, 0, 1 is minus 1. 0 minus 1, 1, 0 is 0. 1, 0, 0, 1 is 0. 1, 0, 1, 0 is 1. Yeah. Okay? So that's the matrix that will show you reflection along y equal x and rotation 90 degrees. If we do it the other way around, 0, 1, 0, 1 is 1. You can already see it's different. 0, 1, that's 0. 1, 0, 1, 0, 0. 1, 0, minus 1, minus 1. You can see you get something completely different. Yeah, sometime it will be the same, but sometimes it's not. Okay? Right, again, I'll pause here and we're going to move on to the example. Right, hang on, I'll just erase the rest. Okay, cool. So this is the question from last week's exam. They tell you we enlarge a shape by a factor of 2 over square root 2, and then we rotate it by 225 degrees. Now, one thing I'm learning here together with you, they don't say is it clockwise or anti-clockwise. What do you reckon they mean if they didn't say? So 225, which direction is it? It must be anti-clockwise. If they don't say anti-clockwise, it must be 25. It must be this. This is 225. Okay? Right. Factor of 2 over square root 2. Personally, I straight away, what is 2 over square root 2? I just write it as square root 2. Do you know that business?
Yeah.
Okay? 2 over square root 2 is like square root 2 times square root 2. 2 is square root 2 times square root 2 divided by square root 2. I just kind of, in my head, just make it a bit easier. Okay? Right. Okay, so now I need to use the two matrices. Okay? And they're asking us, obviously, to find a single matrix to represent this transformation. What will be that one? What matrix am I going to write here? The enlarging or the rotating?
Enlarging.
That's the enlarging. Because this is the first step and this is the second step. So the first step needs to be on the right. First step always needs to be on the right, remember? Because you will multiply it here by your x and y's, whatever it is. Okay? I don't need the x, y's, just to show you that's the first. Okay. Right. What is, anyone remember enlarging? What kind of matrix I use? Okay, I can tell you. It's, okay, it is a scalar, but what I did tell you is basically the identity matrix. If instead of 1, it will have the scale factor inside. So you should have square root 2, 0, 0, square root 2. Okay, I'll hold on to that scalar. Well, not hold on, I'll say it now. Okay? What if you multiply a certain vector by square root 2, 0, 0, square root 2? Okay? What is it really? It's basically
Square root 2 times x.
Square root 2 times x, square root 2 times y, which is basically square root 2, like you said, a scalar, times x, y. You're absolutely right. Okay? But I'm going to leave it like this. I'll show you that you get, either you use scalar or use it like that, you'll get the same thing. Okay? Rotation 225, we got to use the formula you do get given in the test. Okay? You don't need to remember it. Please tell me what it is. It's sine theta. Is it sine theta? What is it?
Cos theta minus sine theta.
Okay, so cos, now instead of theta, I'm going to write 225. So
minus sine.
Hang on, I need a bit more space. Cos 225, yeah?
Minus sine 225.
Minus sine 225.
Sine 225.
Sine 225 and cosine 225. Okay? Now, I can just already put what that cost 25. Okay? I'm going to write what is cost 225. You can put in the calculator. I've done it.
Well, it's the same as minus cos.
What you get is you get square root 2 over 2. So it's square root 2 over 2. No, minus. Minus square root 2 over 2. And here you get square root 2 over 2. And here you get minus square root 2 over 2. And here you get minus square root 2 over 2. So all I did is just use the calculator. It's actually a special angle. Okay? But never mind. This time of the day, you can use the calculator. Okay? I've written it all there. Just checking that I've written it right. I hope I'm not making any mistake, but you guys can check it. Okay? And then we got to time it by square root 2, 0, 0, square root 2. Okay, it's actually not that bad. What is minus square root 2 over 2 times square root 2? It's minus 2 over 2. That time that, okay, square root of 2 times square root 2 is 2. I've got a minus, so it's minus 2 over 2, which is minus 1. Okay, I'll write it down straight. Minus 1. Okay, that time that is 0. Then, that time that. Okay, so that times 0 is 0. That time that is going to be positive 1. So 1. That time that is minus 1. Plus that is 0. And then that time that is minus 1. Let me just check. That's what I got also at home. Hopefully I'm not making a mistake. Okay, so that's the matrix. Just for what you mentioned, Olivia, you could, instead of writing this identity matrix, you could have just write that as square root 2, just multiplying it by the scalar. Okay? And then here I will put the the matrix. I'm going to write that down. Instead of cosine 225, I'm going to write it down here. Minus square root 2 over 2, square root 2 over 2, minus square root 2 over 2, minus square root 2 over 2. Instead of multiplying it by a matrix, I can multiply it by a scalar. And in any case, I will have, that's minus 1, that's 1, that's minus 1, minus 1. You get the same answer. Okay? So these are the difficult ones. Okay? A combination of matrices, or where you're giving a reflection or a rotation and you need to find the angle. Cool. That's it.